Here we have a 13 kilogram mass that's moving along a horizontal surface, and it's acted upon by an 87 Newton force in the direction of its motion. The coefficient of kinetic friction is 0.22. Find the mass's acceleration. So in terms of variables, this is our situation. We have a mass, it's already moving to the right, let's say. There's an applied force that is in the same direction as the mass is moving. We have a coefficient of kinetic friction, and we want to know the acceleration. So let's go ahead and put the numbers in. There's our mass. There's our 87 Newton applied force. That will be the weight force, which is calculated by taking m times g. I'm taking a little bit of a shortcut. This number, 127.53, is m, 13, times g, which is 9.81 meters per second squared. We're going to assume we're on Earth. We have a normal force that points upwards, and we have a kinetic friction force that opposes the motion. So let's write a Newton's second law equation. Let's do the perpendicular direction first. It looks like from our free body diagram that we have the normal force upwards minus 127.53, which is m times g, and that should equal the mass, which is 13 kilograms, times the acceleration perpendicular to the surface. This mass will not be accelerating perpendicular to the surface because it's not going to suddenly jump off the surface or be sucked into the surface. So the right side of the equation turns into 0, which means that the normal force is, in this case, numerically equal in magnitude to the weight. This is going to prove useful when we do our next Newton's second law equation. I like to choose the direction that the mass is moving to be positive, so 87 minus mu sub k times the normal force. And notice I've put in our known value of mu sub k and our now known value of the normal force. And that should equal the mass of the object, which again is 13, times the acceleration of the object parallel to the surface. Which means everything is known except the acceleration, and we should be able to calculate that. If we divide both sides of this equation by 13 and correctly type that into our calculator, we get a number of 4.5 meters per second squared to the right. Now we have an 18 kilogram mass that's moving to the right horizontally, and it's acted upon by a 165 Newton force that's inclined up and to the right at 33 degrees above horizontal. The coefficient of kinetic friction is 0.26. Find the mass's acceleration. So again, in terms of variables, this is our situation. Notice that our applied force is up and to the right at 33 degrees above horizontal. So from here to there is 33 degrees. Let's go ahead and draw our free body diagram. Our applied force is neither parallel nor perpendicular to the surface. We then will want to resolve that into a parallel component and a perpendicular component. The parallel component will be found by taking Fa times the cosine of theta, and the perpendicular to the surface component will be found by taking Fa times the sine of theta. Check it out for yourself and make sure that Fa, which is 165, times the cosine of 33, make sure your calculator is in degree mode, comes out to be 138.4 newtons. Similarly, 165 times the sine of 33 is 89.9 newtons. There's the weight, which is m, which is 18, times 9.81. That comes out to be 176.6. The normal force we don't know at this time, and we have kinetic friction because this mass is sliding. So let's write our Newton's second law equations. We'll do perpendicular to the surface first. I like to choose upward to be positive, so the normal force will be positive, the 89.9 will be positive, and the 176.6 will be negative. The sum of those forces should equal the mass, which is 18, times the acceleration perpendicular to the surface. Well, this mass is not accelerating perpendicular to the surface, so the right side of the equation turns into 0, which allows us to solve for the normal force, 86.7 newtons. Now, we need that number because when we write our second Newton's second law equation, we need the value of Fn. This thing is moving to the right. I like to choose that direction to be positive, so 138.4 newtons to the right minus mu sub k times Fn. Well, we know what the coefficient of friction is, 0.26, and we just calculated the normal force, so that's another force whose value we know. And that should equal the mass, again 18, times the acceleration parallel to the surface. If we solve this equation for the acceleration, 6.4 meters per second squared.